All right, greetings everyone. Welcome to the fourth part of the video for section 3.3, or fourth and final part, I should say. Just one more example problem to go over here. All right, so we're going to go back to solving inequalities, which we did at the end of chapter 2 with absolute values. And so now we're going to do it with polynomial inequalities. And as we go through this, we're going to continue to use this method of a sign chart to solve these. So looking at this problem, we're asked to solve where x plus 2 times x minus 1 squared is less than or equal to 0. So if you recall, the first thing we want to do, since we're trying to figure out where this is less than or equal to 0, is figure out where this function is equal to 0. So we'll take the expression there on the left, the x plus 2 times x minus 1 squared equals 0. Set it equal like that. And then we know from our study of the polynomials that to find where this is 0, we just have to set each of these pieces here equal to 0. So we'd have x plus 2 equals 0, x minus 1 equals 0. Solving each of those, we get x equals negative 2, and x equals positive 1. Okay? Then the next thing is to draw a number line and mark those values on there. So we'll have negative 2 here, 1 here, and at both of those we know the function is equal to 0. And then what we're going to do is pick values to the left of negative 2, in between negative 2 and 1, and greater than 1. Plug them into the function over here and see what we get. And recall that when we do this, we're looking to see if our answers are positive or negative. Okay, sure, let's do that. So let's choose a number less than negative 2. Let's go with x equals negative 3. If we plug that in for x up above, I believe what we'll end up with there is, so we end up with negative 16. So notice we end up with a negative answer there. So we'll know that for all the values here, it's negative. The sign of the answers are negative. Now choose a value in between negative 2 and 1. So like x equals 0. Plugging that in above gives us a plus 2. Okay, so that tells us that for all values between negative 2 and 1, we have positive answers. And we'll plug in a number bigger than 1, say 2. Oh my lord, come on. Here we go. Let's plug that in above. We should get, let's see, I think it'll be 4 times 9, 36. Let me double check here. Nope, that was wrong. What I just said was wrong. The answer is positive 4, obviously. Okay, so we get plus 4 there. Okay, which tells us that for all the numbers up here, we know that the function or the outputs there are positive. Right? Okay. Let me just, sorry, double checking my work here. All right, so now we're looking for where the function is less than or equal to 0. Which, notice first of all, we see that for all values less than negative 2, so here, right, we have this negative sign here, so we know those are all possible solutions. But also note that the inequality here says less than or equal to, so we're also looking at values where it's equal to 0, so that would also include negative 2 and at 1. So we'll go ahead and write our answer here in interval notation. And we'll first describe all values less than negative 2, so we know we can have negative infinity up to negative 2. In this fact, in this point, we can actually include negative 2, right? Because we're looking for where it's less than or equal to 0. and it's equal to 0 at -2. And then we're going to union that with, well, there's no other intervals where the function equals -2, but we have a single point here, right, at 1, where it equals 0. So what we can do then is say union brackets 1, which means start at 1 and end at 1. So basically we're just taking that point. So this would be our answer here. So -infinity to -2, union 1. Okay, great. That's it for now. Thank you for watching.